Welcome back to the History and Philosophy of Science. This is your Week 4 recap and Week 5 intro, and I want to start with a little bit of housekeeping. I made some grade corrections. It turns out the way that Moodle calculates the grades on the rubrics was not the way that I would do it, so I went back and I made some corrections. And so what you want to do is check your grades. Look down here at your administration block. I'm logged in as a student right now, so this is what you should see. If you don't see this, it might be that you have moved it over, that you have docked it to the upper left-hand corner of the page. So take a look at that. You might need to undock that. But if you click on your grades, I want you to look in particular at for things that you might be missing. In this case, you can see that this student is missing everything except one thing, and they got 47% on that. So make sure you look. If you're missing anything, you have to submit it. You will not get credit for this course without submitting everything with at least a 60% score. Okay, so that's the first item of business. The second is as far as the discussions, most people missed the third part of the Week 4 assignment, which was the discussion. Again, make sure you get those done, please. Make sure that you not only post, but then reply to another student, preferably on Twitter again, but also on the on our forum on the website. Okay, that does it for the bookkeeping. Now let's take a look at Week 4. Week 4 was about the scientific revolution, when, where, and why. First of all, when? Well, I think most of you have got this. I just want to take a look at the graph, because if we look at the graph that we produced Week 1, we get a pretty good idea here. This thing just took off like a rocket, basically sometime between 1500 and 1600. That's when it really started to, the rate started to double every year or more, and we got this real explosion. So we're going to place it probably in the 1500s. And the question of where is actually pretty easy to solve, because if we look at what was happening in science during those times, we're going to pick out, in particular, Copernicus being in the mid-1500s, and another scientist named Vesalius, who was involved in anatomy and physiology. And it turns out that both of those scientists were involved in the same university, which was located in Italy. And the city in Italy where they were located is called Padua. And we've got a nice little picture of it here. This is kind of a historical picture of that city. And so this is in the middle 1500s. And so we can really locate the beginning of the scientific revolution in a very particular place in Europe and even in northern Italy. Okay, it was actually under the control of Venice, I believe, at that time. So we've got the when, we've got the where. By the way, this same university was also, there was a couple other very influential scientists. Galileo was involved there. William Harvey, who kind of elucidated the circulation of the blood, he was involved there as well. So very influential place, key place in this whole history of science exploration. Okay, so the big question though is why? Why did it happen there and then? Now, I hope that you watched the full video about Jared Diamond's book. His book is a very interesting read, by the way, also, so I'd encourage you to get it, Guns, Germs, and Steel, and take a look at it, especially if you're into history. And basically, he's focusing on the question of why did Eurasia pull ahead of the rest of the world, and he points out a couple of interesting things. One is geographically, because it's east to west, oriented east to west, that it was easier for trade to happen because the climate was all the same pretty much along there, and so the crops and everything that were developed could be traded and used all across that continent pretty much. The other thing that he talks about is the fact that there were easily domesticable species in all the areas where big civilizations grew up, and that Asia and Eurasia had more than their share of these sorts of species. And so this gave them, through agriculture, gave them a big boost. See, what agriculture does is it basically makes it much easier to feed the population, and so it starts to free up a lot of time, and we'll get to that in a little bit more detail in a second. The importance of trade, by the way, is very interesting, and this is brought up by a scientist by the name of Matt Ridley, who wrote a book called The Rational Optimist, and he focuses on this concept of trade as being kind of the key piece in the development of civilization as a whole and modern civilization. That when people trade, when they exchange goods and ideas. And that these ideas, well, he talks about ideas having sex. It's kind of like a recombination of ideas that makes new ideas. And so this kind of grows exponentially, as we'll be getting into a lot in your final week, in week 6 of this course. Now, but why Europe? As I said, most of Diamond's theories kind of explain Eurasia's prominence, but don't necessarily differentiate between Europe and other parts of Eurasia, such as India and China, and the Middle East and the Fertile Crescent itself, for example, which was the origin of wheat, which is the key in modern agriculture. He does mention it a little bit, and especially if you read the summary on Wikipedia, he talks about the effect of what he calls the Balkanization in Europe. If you look at this map even, you notice that China, for example, is an enormous country. India, very large country. In Europe, the countries are still divided into small pieces, and basically the geography there, and it shows up pretty good in this little map right here, there's a lot of geographical barriers in Europe that break it into small countries. And what effect that has is that because you have these separate political entities, that it creates kind of a competitive effect between them, and they compete for people, basically. So merchants, for example, could move from one country to another if they thought that the policies there and stuff were better. And so this kind of leads to sort of a Darwinian survival of the fittest between the countries, and leads to improvement in their social, political, technological features, I guess you could say. But to really more fully answer this question of why the scientific revolution happened where and when it did, I think we need to work backwards, okay? And I'm going to refer to the article, the Singh article as well, but what I want to do is start with what is science. So I think you have a pretty good idea from reading Popper and Kuhn and looking at the history of science so far, that it involves a couple of things. One is, I guess you could probably boil it down to this, that the idea of science is that you can look at the world, the physical world, and you can develop hypotheses and theories for how it works, how it always works, and then you can test those theories by making measurements. Okay. Now I think that's a pretty defensible view, according to Popper and Kuhn, and that they would both probably agree with that. So if we define it like that, then we can ask the question of what foundation was necessary for that enterprise of science, for that kind of way of doing things to really take off. And I think we can come up with a few things. One is that you have to believe that the world works the same way all the time. So this concept of an orderly universe is very important. And this is where worldview and religion possibly comes into play. Some historians of science have said that one of the things that made Europe take off and separate from the rest of the world technologically, scientifically, was the monotheistic belief that Christianity carried with it, which basically said that God had created an orderly universe that worked like clockwork. Judaism and Islam also have a similar worldview, by the way, but many of the other countries didn't. Even the ancient Greeks, at least the religious Greeks, basically they looked at it like this. You never knew when a god was going to just kind of get upset at you and do something just random, or maybe you got struck by some god's arrow and that's why you fell in love with somebody, and so on. So a lot of these other countries didn't have that kind of worldview that fostered that. But in any case, you need that. You need a belief in an orderly universe, that everything's not just willy-nilly, that it's not just going to totally change tomorrow. Rocks aren't going to start falling up tomorrow, that sort of thing. So that's the first thing. The other is you need this view of human reason and skepticism. So you have to believe in the competence of human reason to figure the world out. I found a really cool quote. I haven't really verified it, but it was from Leonardo da Vinci, which, by the way, was from Florence, Italy, in the late 1400s and early 1500s. And he says this: if you find in your own experience that something is a fact and it contradicts what some authority has written down, then you must abandon the authority and base your reasoning on your own findings. This, by the way, is very similar to some of the things that Francis Bacon said in the 1600s in England about being skeptical and looking at the world for evidence, for facts, and to figure things out, and to question authority and to question dogmas. So you need this kind of boldness to question dogmas, all right? And I think maybe that's making me think right now of the Reformation and Martin Luther and his contributions in challenging the authority of the Roman Catholic Church. Okay, another thing that you need free time and free money. So you need, well, not free money, but plenty of money if you're going to have time to do experiments and stuff like this. You need to be fairly prosperous. So what you need is a society where there are prosperous individuals who can spend their time doing this sort of thing. And we could add to that and kind of pull in the Singh article here. You need prosperous individuals who are also skilled, in many cases skilled craftsmen, so that they can work these instruments and do these experiments, okay? And they have to be educated. So there's a lot of things coming into play. You need this prosperity. Now, to get this kind of prosperity, you're going to need trade, right? You're going to need a certain amount of economic freedom, and you're going to need technology, okay? So also, technology also plays into the need for precision measurement. So if you can't measure things precisely enough, it's going to be very difficult to test your hypotheses. If you can't measure time well enough, it's going to be hard to measure the speed of a rolling cannonball or something like that. So we need precision technology. And this kind of gets into our question for next week, but we'll get to that later. Excuse me, little kombucha break. Just got into this stuff, fermented green tea. Pretty good stuff. So, as I was saying, we need a few things to build the foundation for modern science. We need a belief in order. We need a belief in human reason and kind of a skepticism of authority, a willingness to question dogma. We need free time, free money, plenty of trade, prosperity, and technology. Okay, we need some technology to build our instruments and to free up time. One of the things that technology does is it frees up time. It gives us more leisure time. Gives us a lot more leisure time. That's one thing we definitely have a lot more of. Interesting thing about free time. This book is by a guy named Peter Diamandis, one of the founders of the X Prize, I believe, and he wrote this book called Abundance. The Future is Better Than You Think. And he's got this quote in here. He's talking about lighting and how technology changes over time and really frees up time is what it does. Today, light will cost less than half a second of your working time if you are on the average wage. A half a second of work for an hour of light. So he's talking about the cost in terms of like your labor, right? How much you'd have to work to pay for something. So half a second of work will buy you an hour of light today. Had you been using a kerosene lamp in the 1880s, you would have had to work for 15 minutes to get the same amount of light. A tallow candle in the 1800s, over 6 hours work. And to get that much light from a sesame oil lamp in Babylon in 1750 BC would have cost you more than 50 hours of work. Think about what that means. That extra free time that started to open up was tremendously powerful, and it still is. Okay, so did Europe meet these criteria in that time period, say the 1500s? Well, for one thing, religion, they were dominated by Christianity, which was monotheistic and had this belief in an orderly universe. Um, God kind of setting things in motion, or at least presiding over things in a regular and orderly way, and humans having a sort of independence. Um, those were, I think, some of the beliefs that are characteristic of that worldview. And also, we have this balkanization effect that we talked about before, which would lead to possibly competition between these different states, which would increase, possibly increase prosperity and technology, as we mentioned before. Okay. Oh, by the way, and both of these things could also lead to the skepticism. Now, it seems kind of weird to say that religion could lead to skepticism, but if you've got a religion that actually is kind of individualistic, which Christianity is, then it kind of encourages reason, then apparently, at least, that's kind of what happened, isn't it? I mean, Martin Luther himself was led by his own faith to question the dogma of the Catholic Church. So I think we have those criteria in Europe, and I guess, I mean, we could talk about whether or not those criteria were met in India and China, for example, and the Middle East, and why they were or weren't. And some of that is picked up in the Singh article, and I've already mentioned some, particularly with respect to the geography of Europe and it being divided into small states. Even northern Italy at the time we're talking about, like in the Renaissance and into 15 and 1600s, was divided into small, what they called city-states. And this kind of supports the same hypothesis that this competition between these smaller countries, the competition for people, for intellectual capital, for economic competition, that sort of thing. By the way, just to mention also another effect, a kind of geographical effect, is when you have a really large country or empire, for example, and this was true about the Roman Empire as well, you don't get this kind of effect of competition because the people can't leave. They're basically trapped in that empire under that authority. If you were living in the middle of the Roman Empire at its height, you really couldn't get out. I mean, there weren't any alternatives. I mean, you might have to travel 1,000 miles just to get to the border, and then they might not let you out. I mean, and some of the same thing in the Eastern empires. So in China, for example, is very large. You can't just walk out and go to the next country and decide to live there. So it was much easier in Europe for people to do that. People were much more mobile. And many historians, I think, have pointed out this sort of effect. By the way, as the article pointed out, there does seem to be a strong relationship between trade and kind of the merchant class and the scientific revolution. For example, even Copernicus himself was involved in finance before he developed his heliocentric theory, or while he was doing that. So these people had reason to be very careful about measurement and about numbers. And the same was true, interestingly enough, about Lavoisier, who was a tax collector, a very precise person, and led him to really question things like the gain of mass by metals when they're burned, for example. Okay, a quick week 5 intro. So that wraps up week 4. Week 5, we're going to flip this question around. Last week we were trying to answer the question of what's the effect of society on science. So what are the driving forces behind science? Now we're going to flip it around. How does science, or how has science affected society? For example, you might say that science's greatest impact is by providing us with new technologies, medical technologies, transportation, electricity, things like that. But what about the impact of science on our worldview, the way that we see ourselves in the world? And we're going to look at both sides of that this week. First, we're going to start by reading an article that's about the relationship between science and technology. And I think I've mentioned this in the past. It's not as clear-cut as you might think, and there's been a considerable amount of controversy, and it's actually very important. For example, Why should the government fund scientific research? It's a good question. So it's a politically hot topic. That's the first part. We're going to start with a discussion of which comes first, science or technology, which kind of begets which. And then secondly, excuse me, we're going to listen to an abridged version of a book by the famous astronomer Carl Sagan, the author of Cosmos. The book is called Demon Haunted World, Science as a Candle in the Dark. And it's really about the scientific worldview and what we gain from taking a scientific worldview and taking this approach to life and to the world. And so it's very important that you listen to this. Now, I'm going to give you a heads up here. You're looking at, I think, over 3 hours of listening there, and then plus you got the article, which isn't too long. So you've got about 4 hours this week of just reading and listening. I've only got one essay for you, though, and then 2 discussions. So I think that'll make up for it. So the second part is you're gonna listen to that book on Karl Popper, and you're gonna write an essay reflection. A reflection essay or response. What I mean is I want you to listen to it and just respond to it. Come up with a thesis statement, come up with a summary of your response, and then write a 5-paragraph essay describing or reflecting on what did you think about what Carl Sagan had to say in that book. And I'm not going to tell you what to say about it. You can agree, you can disagree, you can draw out what you thought was most important, but that's part 2. And then part 3 is going to be another online discussion. Again, I prefer Twitter, but you can use the forum as well. And don't forget to respond to each other as well. And what I want you to do for the last one is answer this question. So what is science's greatest contribution to the world? Is it technology? Is it our worldview? Is it some particular discovery or some particular idea that it's brought about? That's what we're going to do in part 3. And then looking ahead to the last week, we only have 2 weeks left in this course, folks. The last week, we're going to look into the future and what happens if this curve continues to increase its slope.